Couple more examples. Given the equation of a parabola, identify key information and graph it. Okay, so the game here is we want this thing to make it look like the formula. And by now we've looked at this formula table enough that we know that this thing, our goal is to make this thing look like x minus h squared is equal to 4 times some number p times y minus k. And so let's start with the stuff inside the parentheses. X minus h, how do you write x plus 2 as minus? Something x minus something, well, it's x minus a negative 2. That's how you get x plus 2. So that's solved. And then y minus k. Again, it's positive. So how do you write as a negative? Y minus a negative 1 is equal to y plus 1 above. And then we've got 4 here. And so I've already got 4 there, and I need 4 there. So what could I multiply it by? Well, I could multiply it by 1, and that would give me my p-value as necessary. And so, since this thing is positive, we also know that this thing opens up. If it were negative, we'd have a parabola that opens down. From here, we can identify key information. So our vertex, h and k, can be identified properly, h comma k, just from the formula. So our h value, our x value for our vertex is negative 2, and our y value from our vertex is negative 1 from above, from here and here respectively. What else could we identify? Well, we could identify that p-value. The p-value equals 1. That's, we've already got an arrow identifying that. We also noted that it opens up and opens upward. I'm sorry about that. I'm losing my ability to run the computer well. Okay, so it opens up. And so the next thing we're going to do is we're going to graph to find the focus and directrix. You can go through and look at all the complicated formulas they have in the book, but I really think just a quick and reasonably accurate picture will help it make that process of finding those values much easier. So here we go. We'll graph this. We'll put it over to here. I don't know, give ourselves negative 2 in all directions. Negative 2 in all directions doesn't make sense. 2 in all directions. Okay. So our center is, vertex is negative 2, negative 1. And we know our p-value is equal to 1. And we know that this thing opens upward. I'm sorry, I should have said open upward first. So it opens upward, and we know our p-value is equal to 1. So to get to the focus and directrix, I'll do those in blue just for fun. You travel 1 up on the axis of symmetry. There's your focus. And then 1 down, and that gives you a point in your directrix. So your directrix must be this horizontal line, which we can label as y is equal to negative 2. And our focus is equal to what? It's negative 2, 0. So we did it. We've got all the information we possibly need. Looking at this picture, we see that our vertex, well, we already know it, but we're going to write it one last time, is negative 2, negative 1. And our focus is equal to negative 2, 0. And then our directrix is equal to y equals negative 2. And a quick picture is much, much better than memorizing the fact that, well, you got to subtract or add p from it. Just use that knowledge to draw a good picture, and it's easier to pick the point and the value out of the picture, in my opinion. As always, you do you. One more example. Let's see. So we're given an equation, y equals negative x squared plus 10x minus 10, and we say find the vertex. Now, you could totally cheat and use the fact that the quadratic formula can be used to find the vertex, which we've seen in previous courses, but let's do it the new way, the hard way. We're going to put this into standard form. Put it into standard form. Put into, quote, standard form. And what is standard form? Y minus k is equal to 4p x minus h, and in this case the x guy is squared. No, have I got this backwards? I don't have that written down. Just disregard it. What do we need? Well, we need to complete the square. So complete the square. Y is equal to, well, the first step to completing the square is you cannot have a negative in front of the x squared term that we want to work with. Additionally, we want to get that 10 to the other side. So we're going to add 10 to both sides of our equation and get that pesky 10 out of the way. We're just going to focus on completing the square for the x terms. So move that 10 to the other side, so it's y plus 10 now. And now factor out negative 1 to the remaining x squared. So if you take negative 1 times x, you would get negative x squared, just like we wanted to. So what are we going to do with this 10x here? Well, negative 1 times what is going to give me positive 10x? Well, negative 1 times negative 10x. That's always been the easiest way for me to factor out negative numbers, is just to think in reverse the multiplication that would result. Okay, so now we've got ourselves our positive 1 in front of x squared. Now we got to do what I like to call kind of making room. So y plus 10, we're going to add b over 2 squared to both sides, so we'll just make room to add that number. Okay, so b over 2 squared, let's calculate that thing now. B over 2 squared is equal to negative 10 over 2 squared, which is negative 5 squared is 25. I guess the parentheses are unnecessary. So I'm going to put a 25 in here. So what number are we actually adding to the right-hand side of this equation? I'll think carefully here. Sorry, let's put that at 25. Now, negative 1 times 25 means that we're actually adding a negative 25 to both sides of the equation. So on the right, it looks like a positive 25, but you're actually adding a negative 25 when you distribute out that multiplication first. So remember to be real careful with your signs when you're doing this process. And so what do we get when we tidy up the left? Well, tidying up the left, we see that we have y minus 15 is equal to negative 1 times, now this thing is supposed to factor as a perfect square, x times x. What times what? Multiplies to 5 and adds to negative 20, multiplies to 25 and adds to negative 10. Well, 5 and 5, and negative 5 and negative 5 are going to work in this case. So tidy it up further, y minus 15 is equal to negative x minus 15 quantity squared. And from here, we can tell that we have a parabola that opens down. Again, if you have a negative in front of it, it's going to open downward. And we can see that the vertex is equal to, careful here, I've made a mistake. Let's fix it in red. This is 5, not 15. So the vertex is at x minus h. Well, h is 5, and y minus k. Well, k is 15. And again, careful with your signs when you're playing that game. And from there, what else do we know? Yeah, that's where I ended my example, but it doesn't feel very complete. So let's figure it out. It opens down. We're going to go back to that table and look it up. So here we go, arbitrary vertex, and we know that we have a parabola that opens down. So what's the form? So we want to get the x minus h quantity isolated by itself. Okay, I can do that. All right, I don't have an extra slide here, so do I? Do I? Oh yeah, sorry about this. Okay, so I don't have an extra slide. So we want to isolate that x minus 5 quantity. So this is kind of above and beyond where I actually stopped this example, and we're just winging it now. So to isolate the x minus 5 quantity, we're going to put it on the left. Just switch sides. Negative times x minus 5 quantity squared equals y minus 15. And I'm going to slap that in a parenthesis. You don't need to, but it's not going to hurt anything. Now, to deal with this negative, you can divide both sides by -1. That's probably what most people prefer, but I kind of like to think of it as multiplying both sides by -1. Either way you slice it, sorry, it somehow zoomed in on me. Either way you slice it, you're going to divide by -1, divide by -1. You're going to get a negative out in front of it. X minus 5 quantity squared equals negative y minus 15. And we want this thing to look like x minus h quantity squared equals 4p times y minus k. So the game here is I can see x minus 5 squared, that's looking good, and then y minus 15 is looking good. So the game is, how do I make -1, this -1 here, look like 4 times p? So I need a 4. And so how do you write -1 as 4 times something? 4 times something. What's our p-value going to be? Well, so you're going to need to multiply by something. And, well, to make it, since 4 is positive, I got to have this negative here, this p-value. This is 4 times p. So it's going to be negative. And then 4 times what gives me 1? Well, 4 times its reciprocal gives me 1. So to make this thing in the correct format, we see that we've got 4 times -1/4. And our p-value here, p is equal to -1/4. But wait, earlier I said p was always positive because it's a distance. Yes, but in the OpenStax tables, the sign of p tells you whether this thing opens upward or downward. And since it's negative, it opens down, confirming something we already came up with. So you now know the vertex and you now know the p-value, and you can use that to draw a reasonable graph and come up with the focus and the directrix from that graph, which I leave as an exercise.